Hello, my name's Jeremy Belcher from Balfour Beatty, and I'll be giving this presentation on DFMA at the Madison. So the Madison, it's one of the cluster of the tall residential towers at Canary Wharf. There's a red arrow above it in the picture, but not in real life. I checked on Wikipedia the weekend, and we are apparently the 16th tallest tower in the UK and the 7th tallest residential tower in the UK. 5 of the top tallest towers are in that cluster at Canary Wharf, and I think the 6th tallest tower is in Manchester. 25% by 2025. It's Balfour Beatty's off-site manufacture and modular strategy. So how should we be building buildings going into the future? It's about reducing the man hours that go into making a building, putting a building together by 25%. So well documented reasons for that: skill shortage, material shortage, energy shortage, cost of waste, the lack of raw materials. It's published, it's out there in public, no secrets in there, and it was our blueprint for investigating what could be done at the Madison, where we received the design as a sort of vanilla scheme from the designers. It was there for us to introduce, if you like, DFMA. So planning for DFMA, it's all about getting the balance right. So Sir John Harvey-Jones there on the right-hand side, a nice little quote there. Planning is an unnatural process. It's much more fun to do something. And the nicest thing about not planning is that failure comes as a complete surprise, rather than being preceded by a period of worry and depression. So bathroom pods. So we Balfour Beatty had identified that we wanted bathroom pods to be incorporated into the building. We didn't want to build 482 individual bathrooms of the quality required by make, of the quality expected by the client and the purchasers, one by one, in situ on site. So we had a back to front procurement route here. So this isn't proper DFMA. So we had a design already, and we had to go out to the market to find out who could manufacture that design. And we ended up with the Stercole bathrooms in Italy, 3 days away, but we still call it a just-in-time delivery system with them. But as I said, 482 individual pods, 3 levels of specification, and again, because the building wasn't designed for pods, there are some different pod layouts around in the building. In fact, there were 17 different bathroom pods, shapes and sizes, and you could double that because there's some left-hand ones and some right-hand ones. So everything that's not the way to do it. But we didn't have a time to redesign the whole building to suit a standard product from one of the bathroom manufacturers, off the shelf product, so to speak. So what we did with Stercole, although we had 17 unique pods, we standardized really on the wet wall, the wall that has the basin in it, the shower, the WC, and the bath. So that's a standard back wall, and really the variation we built into the walls, if you like. So the door might be on the front of the room, on the left-hand side or on the right-hand side. It was a room shape that we managed to retain in terms of the variation and to suit the apartment layouts, but we standardized, we designed for manufacture the back wall. So yes, we had to back engineer the pods into the building. So the key issues for us here was the scope. How many of the bathrooms could we convert to pods? How do we make them fit? What are the interfaces with the if you like, the in situ work, and how do we deliver them? So we were lucky enough to have a design where we had a raised floor in the building, 150 millimeters. So you're building a pod, you're introducing pods. They have walls, they have floor, or ours had walls and floors. So we were introducing stuff into the building where we needed a void to put them into, and with the fact that we had a raised floor meant that the bathroom floors would sit within that raised floor void. So that was a good win for us. We didn't have to change the concrete structure. The interface with services, relatively straightforward with pods. You've got a box with 4 walls, and really everything inside the box is going to be provided by the pod manufacturer, and everything outside the box would be, in terms of services, would be the M&E contractor. You just have to draw a line on a drawing, on a pipe run, on a wiring schematic as to who provides what. There was we almost got it 100% podded. But there were so there's 13 bathrooms en suites on a floor. 2 of them were really we couldn't convert them to pods for the very simple reason that there was some structural beams around the core. The two red bathrooms here were trapped behind a beam. So a pod, we couldn't physically push a pod into that location. But all the green bathrooms. On a majority of the floor, all the floors, we got the majority of the bathrooms as pods. As I touched on earlier, you introduce pods, you introduce walls, particularly where you have an ensuite next to a bathroom. You'd have 2 walls where, if you were building it in situ, you'd only have 1 wall. So we had to do an exercise on to trim down and to work with Sticelli to reduce the thickness of walls where they butted up against existing walls, so that we didn't lose any net floor area. And then finally, we had to do an exercise on how we'd physically get these rooms around the building on each floor. If you like, that drove the program of when we needed these items delivered to the site. So it's a 2-stage process in the factory. Really, they build the boxes and then they fit out the boxes, put them on the lorry, send them off to the site. We had a no surprises strategy on site, and the sequence here, the ones with red, we had a sort of reporting process with Sticelli. So they would give us a weekly spreadsheet highlighting when they achieved the milestones on these particular, on each pod. As each pod reached this milestone, we were able to keep track on it, and as part of the snagging process, we went out there when the pods reached stage 6, the fit out was complete. We went out with the architect, we snagged the pods in the factory, they remedied the snags in the factory and delivered them snag free. Designing for assembly. So this is what you can have whatever bathroom you want, but if you can't deliver it into the building, then you can't have it. This is what the delivery sequence was. That same lorry, 3 days later, arrives on site. We pull them out the back, put them in the hoist, up the hoist, onto the floor. Again, service connected, wall linings up. You'd never know they were a pod. Same process here with red numbers. We're a part of our tracking QA process. I'll talk about it a bit more towards the end, but picture 10 shows the coordination that has to go on in terms of DFMA. So you can design for the manufacturer, but designing for assembly, this is where you need a contractor on board to know what you're talking about, what can and can't be achieved. So this is our bespoke hoist that was built for us. It took the largest pod, which was the wheelchair ready pods, and the size of the opening into the hoist was a large pod plus 10 millimeters all the way around. The large picture on the right hand side. So this is I just took this snapshot. Really, it's quite interesting. 2 lorries on our loading bay, one from the right hand side, one from Uganda delivering cladding, and the one on the left was the first pod delivery. And really, the point about this picture is that the frame is only up to maybe floor 10. Cladding's only been started, one floor of cladding, but immediately we are delivering pods to the site. So the sequence was, as soon as the floor became watertight, then the pods needed to get in. You'll see in a slide in a minute, the reason for that really is we had to leave out some of the shear walls in the tower to allow the pods to circulate round to the areas we had to put them in. So there was a structural link to the program and to the delivery program for the pods, because we could only have I think, 20 floors with these openings in the shear walls until we had to start filling them in to enable us to build floor 21. So floor 21 couldn't be built until the infills for the pods had been filled in 20 floors below. Then when I was putting this together, I came across some old documents. I thought this would be a bit of fun. So theory, every contractor puts together a proposal. So this was our theory on how we're going to build it, and now I've got evidence of how we actually did it. So let's have a little look at what the theory was for the installation of the pods. So this is an extract page, or an extract snapshot from our bid proposal. Here's a floor plan of the tower. This is our hoists, personnel hoist, goods hoist, and emergency staircase. How you feed the beast with your hoists. So this is how the bid team told the client we'd be delivering the bathroom pods. Not sure what makes them move, but as if by magic, they come out the hoist, into position, et voila. And this is how we did it. So the pods come with this trolley that bolts onto them, 2 trolleys, on each side. But no magic, just human beings pushing them around. Two and a half tons. And I'd like to think that we managed to achieve pretty precisely what the bid team thought we could do. So now I just thought I'd just touch on some of the other design DFMA at the Madison. So concrete frames, it's almost second nature now. Concrete frames, you have lifts that go in them, you have services that go in them, and you have the way of constructing them, formwork. So yeah, we structural engineers, I think now, they design generic lift shafts that you can have Otis, you can have Coney, you can have Schindler lifts in. So that is, DFMA in action. It's been done for some time. Again, services, you need to know what the services are before you firm up on the design of the concrete cores. So you're designing for manufacture and assembly with the concrete core, and then the formwork. How's it going to be built? How's it going to be detailed to suit the way it's going to be built? We had a jump form, but we did have, as you can see here, just below my head, solid shear walls that we had to puncture with temporary openings to get the pods in. So that was because the pods weren't envisaged at the time the concrete frame was originally designed. DFMA, the cladding, well, again, second nature really. You don't design cladding that you don't think very clearly about how you're going to install it and how you're going to get it to site. So we had 100 individual glazing modules for each floor, delivered by a spider crane a couple of floors above the picture. Quite a neat and tidy way of installing the cladding, because as you can see from these sequence here, we were able to keep our edge protection in place at all times for the installation team. Although they had harnesses on, they were always behind, as you can see on the picture above, always behind the edge protection. But DFMA, second nature in terms of cladding. Services, again, it's something that's done almost without thinking now. Utility cupboards, it's where the hot water comes into each apartment, where the cold water comes in, where the electrics come in, and telecoms. There's 423 of these. We don't want to build them individually. They came from a UK factory. Prefabricated pipework modules distribute the pipework from the risers in the core to the letterboxes above each of the front doors. Key thing here was these are the main circulation routes for the building, so minimize the amount of time it takes to lift up and connect up these modules, less disruption is to the rest of the site. So some conclusions to our exercise in DFMA at the Madison. So yes, bathroom pods. The beast was fed 11 times a week. So 11 times a week, we got delivered to site a finished snagged bathroom. In fact, the way it did work, sometimes we'd have two delivery or two sets of deliveries a week. So we had 22 finished bathroom pods delivered to site. So the pods were successfully designed for manufacture and assembly. And I'll just really highlight this again. This was you get the size of the pod from the manufacturer. You talk to the hoist company. They give you a hoist you can push the pod into. We gave ourselves 10 millimeters spare. I would recommend to anybody else doing this to give yourself 50 millimeters spare. Even things like these polystyrene corner pieces start to get a little bit in the way sometimes. And the other thing we did with the assembly, we had to go down to the last meter as well. So we did a coordination exercise where we have, particularly where we had en suites and bathrooms next to each other, which direction you push the pod into place because of the way the pipes were detailed to interface with the risers behind. So that is designing right down to the last meter of how it's going to be installed in the building. And when I positioned this bubble, there had to be one slide where it wasn't very good with. So here are my, just with my head out of the WC. So here, quality and program, yes, I can think you see from that the picture on the right hand side. That was the quality we got the pods as delivered from the factory, and I'm very happy to have that in my house. Thank you very much. The middle picture shows our heroic design manager from Balfour Beatty out there in Italy, checking on the snagging of the pods. Again, on the left-hand side, these are my documents these are my tools as a pod manager. It's about what's the delivery program, which pods are coming on that delivery, what date are we going to inspect the pods. We have to go there a week before the delivery is due to leave the factory. And then really there's a whole other presentation to be had on QA and how we use QR codes on all the pods to track them to tie into our snagging tool. But yes, quality and program was delivered. And finally, it's a tall building conference. I thought I'd have a bit of tall building stuff in it. So the large picture, we built a skyscraper. So I think it's called inversion or whatever. But we were above the clouds or above the mist for a couple of times in the 2 years that the tower was going up. And on a clear day, that's what we can see from the dome. And then for all the tall building geeks out there, this is a very nice picture to illustrate a few things about tall buildings. So jump form at the top, and we'd like to think this was a healthy picture of a tower in construction. So jump form at the top, 3 or 4 floors of back propping, safety net, and then a little buffer zone of about 5 floors of program buffer. Then we have the cladding installation, closely following the concrete frame. Cladding installation closely following the concrete frame. And in this zone of about 6 floors, that's where the pods get delivered. That's where the stacks get installed. So the M&E first fix is happening in this zone. And then you can see here where the protection going on the glass, that's where the fit out, if you like, the fit out work starts. So and that's quite a healthy zoning of concrete frame, cladding, fit out. Picture on the right, tall buildings, the views at night, completely different view to the day. Top picture here, I just went up to the top floor to do some detailing, sort out some detailing, and discovered we'd finally built up to the tower crane driver, so he actually had somebody to talk to at last. So I just thought this was a nice photo. So the 4 of the cladding team just having a chat with the tower crane driver. And again, from the topping out, it's just a reminder that these are people, consultants and people who aren't on site, who are involved in building, designing a traditional building. And for DFMA, that team design then build, probably be a lot bigger. And then tall buildings, what it's all about, isn't it? You wake up in the morning, you pull your curtains back, and that's the view you get from level 52 of the Madison. Thank you very much.